This is a video about moment of a force. We all know what a force is. So let us first see what is a moment. A moment is something that creates a turning effect, right? And mostly the resultant is in the same direction. When a couple is acting on a single point, if you have different forces, they may create different effect, but generally the moment due to a couple always acts in the same direction. For example, a person cycling down the road, so his 2 feet, one will go up, the other will come down, but net effect the cycle is propelled forward. Similarly, you place both your hands on a steering wheel, one hand goes up, the other hand comes down, but then the turn due to the turning effect the car is propelled forward. So when you speak about moment of a force which is trying to create a turning effect. For example, um, turning effect about a pivot, a fixed point. I have a pivot here and I have a seesaw here. Sorry. Oh, why am I not able to draw a straight line? I have a seesaw and we reposition the board. Maybe it will work out. That's good. So I have a seesaw which is placed about a pivot, right? Now there is a force, let us say of 500 newtons, that is being applied on the seesaw. It is acting downwards, it is acting this way. So this force is pushing the seesaw down. So what is the moment of the force? The force is 500 newton. So what is the moment of the force? The moment of the force is equal to force into the perpendicular distance from the pivot. So the distance from here to here is going to be, let us say, some 5 meter. So the moment of the force is going to be 500 into 5, right? This is going to be the moment of the force. So obviously it's 2500 Newton meter. Force is measured in Newton meter. Suppose your friend creates a force, let us say a friend is applying a force of 1000 Newton. Obviously the seesaw is going to go this side and it's quite unbalanced. If you have to balance, that's only one way. The total moment has to be equal. If the total moment has to be equal, then your friend will have to shift a distance of to a distance of, let us say, instead of your friend being here, if your friend shifts to a distance, the weight to a distance of, let us say, 2.5 meter, and the force is same 1000. So the moment of a force is going to be 1000 into 2.5, which is going to be equal to 2500 Newton. Is that clear? This is how it works. Moment of a force. This is how it works. It is the turning effect about a pivot. Moment of the force is given by the magnitude of the force multiplied by the perpendicular distance. Let us see a few examples. Okay, first let us see the moment about an axis. When you speak about moment of a force, you speak about moment of a force about an axis. You also speak about moment of a force about a point. Let us first see moment of a force about an axis. The classic example will be the door. So the door will have a hinge, right? The door will have a hinge. Let me consider this to be the pivot. Now the door as a whole moves about the hinge. So about the axis of the hinge, the door moves as a whole. So what happens is, this is the hinge and you will open the door using the handle, which means the force is applied at some distance. So as a result, what happens? The door moves as an entity along one direction. So generally, when the moment of a force about an axis creates a motion about that specific axis, and you will give it as force into distance. This is how you define moment of a force. Now let me speak about moment of a force about a point. So when you're speaking about moment of a force about a point, mostly you consider a rigid body and you speak about moment applied at different places. For example, your seesaw may be a classical example. So in your seesaw, so this is one point which is creating a motion downwards, right? Now this is another point which is creating a motion in the opposite direction. Suppose somebody is trying to push it up, let us say. So which means here about a pivot, this is creating a motion down, and about pivot, this is creating a motion up. This is also creating, sorry, this is also creating a motion down. So how the body is going to move depends on the sum or difference of all these forces. When you see an example, you will be able to understand. Now, I was telling about moment of a force about an axis. Let us see a simple example. This is something I think you all be told about moment of a force. So if I'm applying a force here, right? Just a minute. Okay. Let me assume I am applying a force of 80. Sorry. As a moment, 80. Oh my God. The answer is given here. Okay. So the spanner has a length of 20 centimeters. So when I say the length of 20 centimeter, here is the application of force, and you are applying a force here, which means the force is applied at a distance of 20 centimeter. So the moment of the force is being given here. So distance is equal to 20 centimeter. The moment of the force, the turning effect of the force, M, is equal to 80 Newton meter. So calculate the force required to turn the spanner. So we already discussed moment is equal to force into distance. So what is moment? Moment is 80 is equal to force into distance, which is 20. So force is equal to 80 by 20, that is equal to 4 Newton. Okay, let's consider the example of moment acting about a point, right? Give me a minute. Okay, there are three forces here. Let me consider this as force 1. Let me consider this as force 2. And let me consider this as force 3. We always have to calculate moment of a force about a pivot. So this is the pivot P. Now let me take force 1. So I'll call it M1. M1 is F1 into D1. What is my F1? F1 is 6 into my D1 is 2, which is 12 meter. Now, how is this force acting? This force is acting like this. From the pivot, this force is acting like this. So, what is this? This is an anti-clockwise direction. This is the pivot. And the force is acting this way. So, how do you say? This way, anti-clockwise. The force is acting anti-clockwise, right? This is M1. Now, let us take the case of M2. Again, F2 into D2. What is my F2? F2 is 14 into D2 is 2, which is 28 Newton meter. Here also it's Newton meter. So now look at your M2, your moment from the pivot. It is at a distance which is acting like this way, this, like this means then it will act like this. So this is in the clockwise direction. Okay, so this is in the clockwise direction. Now let us take the case of M3. M3 is equal to F3 into D3. What is F3? F3 is 5. What is D3? Distance is the distance from the pivot. So how far is this force from the pivot? 2 plus 3, 5. So 5, that is equal to 25 Newton meter. Now look at this force from the pivot. It is acting like this. This is the pivot. From the pivot, it is acting like this. So what is the direction of the force? Anti-clockwise. So this force is also anti-clockwise. So what will be the total moment? I have two forces acting anti-clockwise. So let me add both of them up. 25 plus 12. I have one force that is acting clockwise, minus 28. So what do I have here? 37 minus 28. So I will have 9 Newton meter acting anticlockwise. Clear? So when you are speaking about moment of a force about a point, you are also concerned about the direction. If you are not concerned about the direction, when you are applying a force, you will not know how to open a bottle. You will not know how to unscrew a bolt. So the direction is also important. Now let me speak about moment of a force about a point. Let me give you another example. Right? Okay, now let us consider this particular example. I have three different forces. F1, I'll call this as F2. I'm sorry. I'll call this as F2 and I'll call this as F3. Okay. Now, first let us find F1, F2 and F3 and then we'll find the moment of these forces. Now, when I speak about F1, it is at an angle. So, which means I have to resolve it into X component and Y component. So, F1X. Now, if I draw a triangle here, right? So, my X component, which is this part, is given by the opposite side, which is given by the sine. So, F1 into sine theta. So, what is my F1? 250 into sine 30 and that has given me, I calculated it, which is 125 Newton. What is F1y? F1y is F1 cos theta, which again is 250 into cos 30 and that has given me 216.5 Newton. I think I'm right. Yeah. Now you'll have to calculate F2y. F2y, sorry, F2x. F2x and you'll have to calculate also F2y. Now, your F2, now let me complete a triangle here. So, this is the x component, which is the adjacent angle. So, you will have F2 cos theta, which is equal to 300 cos 60 and that works out to be, I think it's 150 Newton, right? Because this is the adjacent side. Your y component is the opposite side. So, it is F2 sine theta. So, that is 300 sine 60 and that works out to be 259.8 Newtons. Now, this is something I'm not calculated. Maybe you can calculate it. Similarly, F3x and F3y has to be calculated. What is your F3x? This is your x component, right? So F3x, this is your x component, which is again going to be your opposite side. So you will have F3 500 into sine 30 and you'll also have here 500 into cos 30. Let me try to calculate it. So you will have here, let me see, sine 30. So I have here 250 Newton, right? So for F3x, I have 250 Newton. What is F3y? So what do I have here? Cos 30, right? So 433 Newton. Okay, now having calculated these values, now we'll have to calculate the moments of the forces. What is the moment of a force? Moment of a force is the turning effect of a force. Now let us take F1x. X component is the component along this x direction. Now any force acting along this is not going to create a moment. Acting along this direction, see, this way, is not going to create a moment, which means we can do away with the x component of this. Similarly, look at the x component of F2. That is also acting along this direction, which is not going to create a moment. You can also do away with this. Okay. So, how is your F1y going to act? So, this is my bar. The force is acting, is pushing it down. See, it is pushing it down. So, what does it do? It is creating a moment along the clockwise direction. So, moment of F1 is equal to 216.5 into, what is this distance? 2 meter. find this sum, okay, along the clockwise direction, right? So let us find this out. So what do I have here? 216.5 into 2, I have 433 Newton meter. Now, similarly, F2x does not create a moment, only F2y creates a moment. So I will have M2. This is M1 working on the along the clockwise. So I have 259.8 newtons, right? 259.8 into what is the distance from the pivot? This is the pivot, right? Don't calculate the distance from here. Calculate the distance from the pivot, which is equal to 259.8 into 5. 259.8 into 5, and that gives me 1299 Newton meter, also along the clockwise direction. Now let us take F3x. Should I do away with F3x? Absolutely not. This F3x is acting like this. What is it doing? It is pushing this L-shaped bar up. This F3x is pushing it up, right? So F3x is a force which is acting in the clockwise direction. So what will you have? You will have M F3x is equal to, so what is it? I have 250 Newton, right? Am I right? 250 into, what is the distance along the x-axis of this force? Into 5. Into 5. So I have 1250 Newton. How is it acting? It is acting in the anti-clockwise direction. So what do we now have? F3y. Okay. So that is 433 Newton. And what is the distance of this along the y-axis? Along the y-axis from here to here, it is going to be 4 meter. 430 into 433. Sorry, it's not 4330. 433 into 4. So, give me a minute. So, I'm going to have 433 into 4. So, what is the answer? 1. So, I'm going to have here 1732. This is also Newton meter. This is also Newton meter. This is also in the clockwise direction. So how is this bar going to move? The total moment is equal to, you have to add all the clockwise component, which means 433 plus 1299 plus 1732 minus, you'll have to subtract the anti-clockwise component, which is going to be 1250. So what do I get here? 433 plus 99 plus 1732 minus 1250. So is equal to 2214 Newton meter in the clockwise direction. So this is how you'll have to work out problems in moment of a force. You may have n number of forces. Calculate the moment of each force along with the direction, whether it's going to be clockwise or it's going to be anti-clockwise. Then you will know the entire moment which is acting on a particular ball, right?